A supervillain wants to blast all of our final exams into the sun, so we won't be able to do our physics class anymore. His rocket blasts off with a starting velocity of 25 meters per second and reaches a height of 700 meters before Mr. Minchesky, furious, flies in to stop the rocket. The velocity of the rocket was 240 meters per second when Mr. Minchesky heroically stopped it. I want to know A, how much time did Mr. Minchesky have to leap in and save the day? And B, what was the rocket's acceleration during flight? So, as always, let's start by setting up our equations. S equals xi plus vit plus 1 half at squared. A is equal to vf minus vi over t. Our variables that we are going to be looking at are xi, vi, vf, a, and t. So, our initial velocity, it tells us right there is 25 meters per second. Our final position when the rocket is stopped is 700 meters. And our initial position, we're not given anything different, so we're going to decide that we are starting at our reference point of 0. Our final velocity is a 240 meters per second. All right, so now that we have our variables set up, we can see that we don't have acceleration or time. We're missing variables from both of these equations, and we will need to substitute in. So let's rewrite our S equation with our acceleration equation substituted in. Vf minus vi t squared. Get rid of that t. Okay. Now, let's plug our numbers in and start solving. So S is 700 meters. Equals xi. Xi is 0, so we can get rid of it. Our vi is 25 t plus a 1 half vf of 240 minus vi of 25 times t. Let's simplify all this down. It's going to simplify to 700 equals 25t plus 107t, 107.5, sorry. And 107.5 plus 25 is going to be 130, what is that, 2? 32.5t. Divide both sides by 132.5. That should give us t. Our time is 5.28 seconds. Very nice. 5.28 seconds. And our acceleration. We can plug our time right back into our acceleration equation, and that will give us A equal Vf minus Vi over T. A equals 240. I wanted to say 340. I knew that wasn't right. Minus 25 over 5.28. Our acceleration is going to be 40.72 meters per second squared. Beautiful. 40.72 meters per second squared. Putting a box around my answers. And that problem is solved. Nice and simple, right?